Hello, this is question 2 on your Mechanics 2022 paper from Edexcel, and I would say super typical question, so it's worth it to take some time to understand it. A rough plane is inclined to the horizontal at an angle alpha. This is tan of the angle. Small block B of mass 5 kilograms. This one is held in equilibrium on the plane by a horizontal force, X newtons, as shown in the figure. Block B is modeled as a particle. Magnitude of the normal reaction is this one, so I'm going to mark this, the 5 kilograms and the normal reaction. And using the model, we have to find the magnitude of the frictional force acting on B, and then they ask us the direction of the frictional force. So first, we are going to draw all the forces that we have, right? So we have the weight of the block. We know the mass is 5 kilograms, so this is going to be 5g. We know the normal reaction is perpendicular to the surface and is 68.6 newtons. And I have a frictional force. You have to think, and they ask you as a second part of the question, in which direction is that force? It's not moving, it's in equilibrium. That means the direction of the frictional force is against the tendency of motion. So if imagine this is super slippery like ice and you are pushing this direction, so the block will go up. It's not the case because it's rough, so it's in equilibrium. That means that the friction is down, yeah, it's stopping the block of moving up. So my friction is, let's say, in this direction, friction, and this is what I need to find. Remember, when we work with inclined planes, we work with our forces in two directions, parallel to the slope and perpendicular to the slope. So I have two forces here that are not in the directions that I want. So what I'm going to do is to find the components in those two directions. Remember, this angle is alpha. So the component in the perpendicular to the slope of the weight is pointing that way, and it's going to be 5g cos alpha. This is the adjacent in this right angle triangle, and the horizontal or the parallel to the slope component is going to be this one, and it's going to be 5g sine alpha, because this length is this length and is opposite. And now the same with this one. So this one is this is alpha, so alternate angles, this is alpha. So I'm going to find the components. I have one perpendicular to the slope component, and I think I'm going to use a different color so you don't mix them. So I have one perpendicular to the slope pointing against the block, which is x sine alpha, and one parallel to the slope and pointing up, yeah, because this one is pointing up, which is x cos alpha. Yeah, so those are all the forces that you have, and the pink one are the components of the weight and the green one are the components of x. So what we need to find is this friction. It would make sense to work with the forces parallel to the slope, right? But if you write your equation of motion or equilibrium, in this case here, you have two unknowns. So that means we have to use as well perpendicular to the slope to help us to find one of the unknowns. So if we work perpendicular to the slope, really we have only one unknown, so because we know the normal reaction. So what we're going to do is solve perpendicular to the slope, find x, so resolve parallel to the slope and find friction. Yeah, so let's going to do that. Perpendicular to the slope, so for A, the first part, if I resolve perpendicular to the slope, my force is pointing in this direction, which is only this one, the blue one, is going to be these two down over against the slope. 68.6 is going to be 5g cos alpha plus x sine alpha. X sine alpha. When they give you the tan of the angle and the numbers are nice, like these ones, remember it's better to use the triangle. So this is alpha, tan is 3/4, and if you use Pythagoras, this is 5. So instead of doing tan minus 1 and then use that number, it's much better to have this. So cos alpha is 4/5. So this one times 4/5, and sine alpha is 3/5, and this is 68.6. And from here, the only unknown that you have is x, and x is 49 newtons. Just solving that, yeah. Now, what I do is solve parallel to the slope, which means that forces pointing down the slope, which is the friction, the blue, and the pink, 5g sine, is going to be the same that the one pointing up, which is the green one. Yeah, so friction plus 5g sine, friction plus 5g sine alpha is going to be x cos alpha, which is the one pointing down. So friction is going to be x, which is 49, cos alpha, we say is 4/5, minus 5g, sine alpha, we would say is 3/5. And from here, friction is 9.8 newtons. So that's my friction. And then they say, state the direction of the frictional force acting on B. They don't ask us even reasons. Yeah, it's 1 mark. So the friction, we have here that is down the hill. Yeah, because it's stopping the block of sliding up. And so for the second part, you can say is down the hill or down the slope, because they don't say it's a hill. Yeah. Then horizontal force is now removed and B moves down the plane. So given the coefficient of friction is this one, 0.5, find the acceleration. And it's a lot of marks. So you have to think that every time you add or remove forces in a friction question, your friction directions can change. So you have to check. Yeah, in this case, I'm going to do like a new sketch, and I have it here. Without this force. So I'm going to delete this force here. We don't have this force anymore. And we are going to draw the forces that we have. So we have the weight, hasn't changed, 5g. The normal reaction, you have to be careful because the normal reaction now has changed because I have removed a force. And if you see this diagram, this normal reaction is balancing these two forces, and this one is gone, which means this normal reaction now is going to be different. Yeah, so that normal reaction, and that's it. I don't have any other forces. What I have is the components of the weight in my two directions. So I have here, I have 5g cos, 5g cos alpha, which is the same, and this one is 5g sine alpha. And the whole block is moving down with an acceleration, and that's what I need to find. And friction, sorry, I'm missing friction. The friction is what that changed direction, because now the block is sliding down, so the friction is the other direction. So remember, before it was down the hill, now it's up the hill. Just because it's moving down. So now I need to find, what do I need to find? The acceleration of down the plane. So if we resolve down the plane to find the acceleration, our equation of motion, so force, resultant force is mass acceleration. Resultant force is going to be 5g sine alpha down, 5g sine alpha down, minus friction up, and this friction again is going to be different than the one before. Yeah, friction is going to be mass, which is 5 acceleration, and I need to find this acceleration. It's moving, which means that this friction is going to be maximum, which means I can use that friction is going to be mu normal reaction. I know mu is given, and I need to find normal reaction if I want to find this friction. To find normal reaction, I'm going to resolve in the direction perpendicular to the slope, and I'm going to do like in parallel. because it's quite simple. So normal reaction is going to be, so force pointing in this direction is the same that force pointing in that direction. 5g cos alpha. I know what cos alpha is. This normal reaction, so normal reaction is 5g times 4/5, which means this is 4g. Yeah, and that means that my friction is going to be 0. What was the coefficient? 0.5 times 4g, which is 2g. Yeah? So this is my friction. So now I can come back here and I have that 5g sine, which was 3/5, minus my friction, which is 2g, is going to be 5a, and acceleration is going to be g over 5. Yeah, you can leave g over 5, or you can just divide with the calculator, and don't forget your units. Yeah, and that's all with this exam question. And I told you, it's quite popular question. So they change, maybe instead of a horizontal force is parallel to a slope, or they don't give you the normal reaction, but they give you something else. So it's quite common question. Yeah.